Alright guys, so this video is essentially that step 5 I was talking about and how to draw a loose structure and how to determine if it's the best loose structure. So the formal charge is valence electrons minus 1/2 of the bonded electrons minus the non-bonding. So bonding electrons are clearly electrons that are participating in a bond. Non-bonding would be anything that's technically a lone pair, right, or a lone electron. That's how people say it, non-bonding or lone electrons. So the formal charge, our goal for a formal charge is to get everything as close to 0 as possible. And if you have to have a charge, if it's a negative charge, it would prefer to be on an electronegative atom, right? So that's how formal charges work. So let's, one question that you could have on an exam is, what is the formal charge of the F and what's the formal charge of the P on this example? So let's do F first. Fluorine has how many valence electrons? We should be getting pretty good at this point. It has 7. 1, 2, 3, 4, 5, 6, 7. So F is going to be 7 minus, now how many, 1/2 times, now how many bonding electrons are around F? There are 2. 2 of them are participating in a bond, right? So it's 7 minus 1/2 of 2 minus how many non-bonding are around the F? 1, 2, 3, 4, 5, 6 minus 6. Right? So it's essentially 7 minus 1 minus 6. So it has a formal charge of 0. The formal charge on this is 0. So is F happy? Yes. How about on phosphorus? Phosphorus has how many valence electrons? Phosphorus is here, so it's 5 valence electrons. So for phosphorus we have a 5. I promised I'd get markers and I lied, I guess. 5 minus how many bonding are around it? 1, 2, 3, 4, 5, 6. So 1/2 of 6, right? And then minus the non-bonding that are on phosphorus. How many non-bonding are on phosphorus? 1, 2. There are 2. So minus 2. So what is 5 minus 3 minus 2? 0. Well, look at that. Phosphorus is also happy. So it has a formal charge of 0. By the way, your formal charges should add up to your net charge. PF3 does not have a net charge. It's not like a PF3 minus or PF3 plus. So the formal charges should all total up to 0 as well. So down here we have an example that is on the slides. Let's figure it out. HCN. So how many electrons would HCN have? Hydrogen has 1, carbon has 4, N has 5. So we should have 10 electrons. 1, 2, 3, 4, right, plus 5. So we should have 10 electrons. Both of these structures have 10 electrons. 2, 4, 6, 8, 10. 2, 4, 6, 8, 10. Oh, so Carlo, they're the same, right? Well, actually, this is that 5th step I was talking about. We have to double check that our formal charges are happy, right? So the formal charge on H is going to be 0 because 1 minus 1/2 of a bond minus 0. So H is the same in both cases. But let's check out what the deal is with carbon in these cases. Carbon, like we said, has 4 electrons as a valence electron. So carbon's going to be 4 minus, okay, how many bonded electrons are around it? 2, 4. So 1/2 of 4 minus 1/2 of 4. Okay, how many non-bonding? So how many lone electrons are on carbon? There aren't any, not in this example. So it's essentially 4 minus 2. So carbon has a charge of plus 2. Ugh, that's already icky, isn't it? Having a formal charge. Ugh, I don't like it. Nitrogen. Nitrogen has 5 to begin with. We're right here. So 1, 2, 3, 4, 5. 5 valence on nitrogen. So 5 minus 1/2 of the bonding. How many bonded electrons are around nitrogen? 2. 5 minus 2. Oh, I'm sorry, it's 1/2 of the bonding. Probably if you're playing at home, you were screaming that. Minus the non-bonding. 1, 2, 3, 4, 5, 6. Minus 6. Okay. So it's really 5 minus 1 minus 6. That's a minus 2. So N is minus 2. Ugh, I don't like that at all, right? We have an electron deficiency and we have somewhere where it's 2 electron rich. So I don't like this difference. So when you draw out this structure, you'll notice that carbon has its octet is not satisfied, is it? It only has 4 electrons around it. So how do we remedy that? Well, instead of adding any electrons, you just take these 2 and put them right here. Okay, then carbon would have 6 electrons around it. Is that good enough? No, take another pair. Move it right there. So that's where we get the triple bond. So triple bonds only come about in these Lewis structures when you have a situation where the central atom is not satisfied with an octet. So let's do the formal charge for this one just for funsies, okay? So carbon comes with 4 electrons minus 1/2 of how many bonded electrons around carbon? 2, 4, 6, 8. So 1/2 of 8. How many lone electrons does carbon have around it? None. It doesn't have any, right? I don't see any dots here. So it's minus 0. So it's 4 minus 4. Easy math. 0. Much better, right? We're looking to have everything close to 0. Nitrogen, let's check nitrogen out. Nitrogen comes with 5 valence electrons. We have 1/2, so minus 1/2 of the bonded. It looks like we have 2, 4, 6 bonded electrons around nitrogen. So 1/2 of 6 minus, how many lone electrons are around nitrogen? 1, 2. 2. So it's 5 minus 3 minus 2. That's a big fat goose egg 0. So that's why, yes, technically both of these structures have the correct skeleton. They have the correct number of electrons. But if we check the formal charges, we'll see that this is a much more viable structure and it's much more stable because the formal charges are all closer to 0, which is what our goal was. So, thanks for watching, and that was formal charge.